All right, moving on to number 28. Which of the equations are true based on an exponential function? So again, the steps to turn it into a log. This is ready, will be 3 log base 3 of 81 equals x. So right there, I can say that the correct answer for this one already in this step, it's number 6. Now, if I would have wanted to use the exchange-based formula to figure out what is the value, I would divide log of 81 divided by log 3. Okay, so right there, I can say that another good answer is number 5. Now, if I put this in a calculator, again, you would put it in a calculator, a regular calculator, as dividing it this way. Okay, or if you put it into a decimal calculator, the value would be 4. Okay, so number 1 is also a correct answer. All right, moving on. All right, so number 21. You're doing an interest, growth, or decay, and this is your formula. Again, A equals P, which is a value, initial value, 1 plus or minus the rate raised to a T. So here it says, write an equation modeling in this situation. So here we got in the last 12 years, an initial population was 38 buffalo, and the state park grew by 7%. Okay, so A equals my initial value was 38 buffaloes, and it grew, which means I'm going to add 1 plus, and the rate was 7%. 7% is going to be converted to a decimal to be able to add it. So it's going to be 0.7t. Okay, I'm writing a equation model, so I'm not going to put 12 years in there because the years can change. So this is the model that the initial amount of buffalo will stay, and the rate they grow will also stay. Okay. Now for B, it says state how many buffaloes there would be after 8 years. Again, I would do 38. 1 plus 0.07 now raised to 8th power. If you put it all in a calculator, you're going to get 65 buffalo. Okay. All right. Number 30. In 1990, the population of Austin, Texas was 596,297. During the next 10 years, the population decreased. So it went down about 3.1%. Okay. So what do I know? I know that it decreased, which means I'm going to subtract. I also know that 3.1%, it's going to be 0.031 in decimal. Okay. So according to my formula, I have initial value of 596,297. Okay, I'm going to subtract the rate from 1. Okay, and my time, that's my formula. Now, it says write a model giving the population. So this is, sorry about that, guys. I keep making announcements. All right, so that's a model. Okay, that's a general model. Now, for let me see. Okay, yeah. So now for B, it says what was the population in 2015? Okay, so again in 2015, you need to go from 1990 to 2015. So that's 2015 minus 1990, which is 25 years. Okay, so that means if I am putting into my model that I just created, we started with 596,297. It was decreasing by 0.31%, and now my time is 25. If you put this all into a calculator, you should get a value of 271,367. Okay, so 271,367. All right. Now, see, it's saying when will the population be below 300,000? So this is giving us an outcome. So now we're solving for when, which is t, okay? So now, instead of my A right here, I'm going to put my outcome of 300,000, okay? Now, my initial was 596,297. It was 1 minus 0.031, and now I do not know the time, okay? So I am going to combine what's on the inside here. So this is going to be 0.969 t T, and then I still have 5,96297 here equals 300,000. Now, this is an exponential function. So this is my base right here. So that means I need to turn it into a log, but before I do that, I gotta move this big number out of here. So I'm gonna divide by 5,96297, both sides. Okay, this is gonna cancel out. The left side is gonna give me 0.5031. And then I have 0.96969 T on this side. Now, excuse me, I am ready to turn it into a log. So again, this is my base, just like 2 to the T, okay? Or 3 to the T, whatever, okay? And I would have a number here, okay? Again, I'm going to turn this into my log. So this is my base. So that means my log of this number that holds the T. Now, I'm going to put the other number here and the T on the other side. And guess what? You're going to use Desmos to calculate it or use the exchange rate formula. So log of 0.5031 divided by log of a base, which is 0.969, okay? You are going to get a T value of 21.8, okay? So you're going to round it up to 22 years, all right? So again, you're treating that as an exponential function, okay? You're turning this into a log, all right? All right, now question 31. Move that up a little bit. All right. Now we're doing compounded interest. So remember, compounded interest is when you use the same formula, but now you're dividing it by either. If you're investing in quarterly, if you're investing daily, that means your money are going to grow daily, okay, which is 365 days, weekly, which is 52. You have quarterly, you got 4, and weekly. I'm sorry, no, monthly. You got 12, okay? So that just means how many days, how many weeks, how many quarters, and how many months are in a year. So you're treating it in the same way, formula. It's just this time you are going to divide the rate by that amount of whatever it is, compounded, how often are you getting your interest? And then you're going to take the same amount and multiply it by time, okay? So here it talks about you deposited $2,000, okay? So here it goes, 2,000. You start with that, okay? Now, in your account that pays an interest, so interest means 1 plus, of 4.75. So an interest of 4.75% is going to be a 0.0475 in a decimal, okay? So you're going to add 0.0475, okay? Now, what will the balance quarterly, compounded quarterly? So anytime you have a word compounded and then either quarterly, monthly, daily, or weekly, you are going to divide that interest by that, okay? So quarterly means there's 4 quarters in a year. That means I am going to automatically put the 4 up there on the top, okay? And now it's asking us, now I'm going to multiply by a time. What will be the balance in 5 years? So again, you're putting all of this into a calculator, okay? And you're going to get an amount of $2,532.60, okay? So that's how much more money you're going to earn, $532.60, if your interest grows every quarter by 4.75%. Okay? All right. Next question talks about you deposited $2,000 in an account that pays 3.75% interest compounded monthly, so that's 12. Okay? How long will it take to the balance to reach 5,000? So now you have an outcome. So that means instead of the A, we're going to have 5,000, okay? Because you want to know how long is it going to take you to get there. So you started again with 2,000. The amount is growing. You got 3.75% interest, so that's 0.0375 in decimal. So that's 0.0375 in decimal. You're going to divide it by the compounded monthly, it's 12, and that 12 is going to go right here to the time. Well, unfortunately, we don't know the time. That's what we're solving for, okay? So again, it's going to be an exponential function. You're going to move into a log, but first you're going to combine all this. Please make sure that when you're putting it in a calculator, okay, you're adding the fraction to the 1, meaning you don't make sure that you have parentheses. So you're adding 1 plus the fraction, not 1 plus the top divided by 12, okay? Because that's a lot of mistakes. So this is 5,000 equals 2,000. Now on the inside, I'm going to get, let me see. Okay. On the inside, I'm going to get 1.003125, okay? And try not to round it up. Raised to a, let's see, raised to a 12t, okay? So now I want to turn this into a log, but I got to get rid of this 2,000. So I'm going to divide both sides by 2,000 first, okay? So now on the left, you are going to get 2.5 and then 1.003125 raised to a 12t. So again, if anything is raised to an unknown, you know, that's an exponential part. So you're going to have to turn it into a log. So again, this is my base, all right? So if I'm turning this into a log, I got a log of a base 1.003125 of what's on another side, 2.5, okay, equals 12t. So now you can take this log and put it in a calculator. I can do log 2.5 divided by log of a base of 1.003125. And what I'm going to get is, all right, so what I'm going to get is 293.67 equals 12t. And now, of course, I have to divide both sides by 12, okay? So if I divide this by 12, my final answer is t equals 20, I would say 5 years. It's 24.5, which is 25 years, okay? So that means it will take 25 years with this rate to get monthly earnings to get $5,000. All right. All right. Moving on to the next one. All right. So now compounding continuously. So that's our PERT formula with an E. Okay. All right. So first one is compounded continuously. So anytime you have a word continuously, you're going to use the formula with the E, with a PERT. So the first question is just simply saying you take out a loan of $4,800, so $4,800 with a charges of 16.5%. So again, $4,800 is your initial amount. Then there's a E, then there's a rate. Of course, 16.5%. It's going to be 0.165, okay? So it's going to be raised to a rate of 0.165, and we don't know the time, okay? And this is your A. So this is the formula. If we're looking at our answer, it is going to be D, okay? It is not C because you have an extra 0 there for the percentage, and that is not correct, okay? The correct answer is D. All right, and then moving on to number 34. All right, he says that suppose you got $500 invested. Again, my formula is A equals, okay, initial value, E times T, rate times time, okay? All right, so I got $500, and then the rate is 6.8%. Okay, so again, that's 0.068 and a decimal. And then it's saying find the final amount after investment after 10 years. So that's my time. Time is 10 and initial value is 500. Okay, so I'm going to plug it in. So A equals, I'll plug in 500 for P times E raised to a time and rate. So 0.068 times 10. And again, if you put all of this into a calculator, there's an E button in there, or Desmos, your final amount is going to be $986.94. Okay? So that's saying that, you know, with that rate for 10 years, you're going to earn about $486.94. All right. Now, next question, 35, talks about how many years. So I already know I'm solving for T, okay? It takes for investment to double. So this is my formula, rate times time. So I know I'm solving for T, okay? Please remember, you cannot have more than one variable in the equation to solve for. So meaning you can't have an x and a y and a z to solve for, right? You only have to have either x or the y or a z, because it's just not going to work. So I also know that I want investment to double, and I know that a rate is 9.2%, which is going to be 0.092. So that means I can put in, instead of the rate here, I can put 0.092 times t, okay? Now, it doesn't give me any other values other than double, and I know that I can't have an A and a P and a T, because remember, E has a value of 2.7, okay? So I can't have other variables. But what I do know is that whatever amount I'm going to have here, okay, this amount will double. That means I'm going to have 2 times whatever the amount is, okay? So I can substitute the A with the 2 times P, because whatever the amount here for the money is, so let's just say if I have 500, I know that I want to double of 500 on this side, right? So whatever the amount is, I can do 2 times that P, okay? Now remember the property, anytime I have something on both sides of the equal sign, I can drop it. So I'm going to drop these 2 P's, they're going to cancel out, okay? Why? Because if I would divide it by P and divide this by P, this is going to become a 1 and a 1. So it's just dropped. So what do I have left? I have a 2 left on the left, and I have an E raised to 0.092t, okay? Now, this is an E, an exponential part that I can turn into a ln, which is a natural log. So again, ln of E of the 2, what's on another side, will equal my exponent. Now again, you do not write in a calculator E, okay? It's assumed already. So I can put ln of 2 in a calculator, but before I do that, I can also divide it by 0.092 to solve for t. So now t will equal 7.5 years. Okay? All right, and the last two. 36 says, the number of bacteria present in a culture after t minutes is given as a B equals 100 EK times t. If there are 331 bacteria present after 4 minutes, find K. K is our rate, okay? So we find in K. So they're saying that after whatever minutes, we are going to end up with 4,331 bacteria after 4 minutes, okay? So again, we are going to now solve for K. So again, I got to get rid of this 100, so I'm going to divide by it to have it E by itself. So I'm going to get 4,331, that's 4,331 divided by 10, will equal E to 4K. Now I got an E by itself, so I can turn it into ln. So again, that's going to be ln of 44331 equals 4K. Again, the E base goes here, but I don't have to write it. Okay, so it's assumed. So now I'm going to divide both sides by 4 to solve for K. So K will equal, and again, you're putting all of this into a calculator. Okay, so I can show you guys very quick. Let me do it ln. So again, you can guys do, and it has a natural log. There you go. ln of 43.31. Close the parenthesis. Make sure you're closing it because you're dividing the whole thing by 4, and you get 0.94, and that is your answer. And again, you can use regular calculator as well to do that. Okay, so that's your rate. It's 94%. Okay, 0.94. All right, and then the last one, it says this one is just for fun. Solve this following equation. All right, so you're solving for x, okay? So first, I would like to get rid of, so I want the ln to be by itself right here, okay? Before I can turn it to an e. But before I do that, I gotta get rid of this r square on the bottom. So to do that, I'm gonna multiply it by r squared. If I do that to the left, I'm right, I gotta do it to the left to get rid of the fraction, okay? So I'm gonna have r squared times y on the left and the ln of x over m minus SA. Well, I can't move anything out of this parentheses because that ln, that belongs to it. But what I can do is I can turn it into an exponential function. So I can have a base e, I can raise it to what's on another side, and then I can equal it to the body of the natural log. All right. Now, of course, I'm solving for x right here, so I'm going to get rid of the SA, so I'm going to add SA to both sides to cancel it out. So I get e raised to r squared. Again, you're not solving combining, you're literally rearranging the pieces. SA goes to the side of it, now equals just x over m. Now to solve for x, I gotta get rid of the m, so I'm gonna multiply both sides by m. So this will cancel out, and then I'm gonna have a m times e raised to r squared y plus SA equals x. And that is my final answer. Now, you can also rearrange some letters, okay, in any other way, but this is your final answer.